everybody, it's Mrs. Dunn. We're continuing our discussion of hypothesis testing. Today we're testing a claim about a population standard deviation. We're going to be using our calculator and the chi-squared CDF function on the calculator. So what we're going to do specifically in this screencast is I want you to learn the procedure for testing a claim made about a population standard deviation, and I want you to use that procedure. The procedure requires us to use similar methods to set up the hypothesis test. How we identify the null hypothesis, how we identify the alternative hypothesis. It's going to be similar to what we did with the population proportion and population mean. We're going to be using the formula to calculate the chi-squared test statistic, and we're going to be using the calculator in the chi-squared CDF function to calculate the p-value. I'm going to go through two examples. Okay, so let's get started. First thing we want to talk about is this formula for the chi-squared test statistic. The formula for the chi-squared test statistic requires you to know the sample standard deviation and the population standard deviation and the degrees of freedom. So n-1, remember, is the degrees of freedom. The sample standard deviation is s squared and the population is sigma squared, and that's going to give us the chi-squared test statistic. We'll be using that in both of our examples. So let's look at this first example. Test scores in Mrs. Dunn's statistics class have a standard deviation of 14.1. One class of 27 test scores has a standard deviation of 9.3. Use a 0.05 significance level to test the claim that this class has less variation than other past classes. So the first thing we're going to have to do is to set up the hypothesis test. So you want to identify the null hypothesis and the alternative hypothesis, the level of significance, and whether this test is left-tailed, right-tailed, or two-tailed. Pause the video and think about it and see if you get these right. You try it on your own. So hopefully you realize we're testing whether or not this new test scores have less variation than the other past classes. So our population standard deviation that we're testing is that sigma is equal to 14.1. The original claim is that sigma is actually less than 14.1. Remember, that's the original standard deviation. The level of significance is 0.05. Remember, since this inequality is pointing to the left, we have a left-tailed test. Okay, next step is to find that test statistic. Now, make sure you realize you know this information. The degrees of freedom is 26, one less than 27. The sample standard deviation is 9.3, and the population standard deviation, we're going to use 14.1. When we substitute those numbers into this equation, we get a test statistic of 11.311. We always round those chi-squared test statistics to 3 decimal places. That's what they're rounded to in the chart. So that's what we'll round them to. Now I have this figure up here so that you can understand roughly what's going on here. So remember, the chi-squared distribution is not symmetric, okay? And what's really important that you understand is that as the degrees of freedom get higher and higher, it gets closer to a normal distribution. But when they're really small, it's way more greatly skewed. So the degrees of freedom in this problem is 26. So what we're going to do, remember the p-value gives us the area. The p-value is the area to the left of our test statistic. So where our test statistic lies, if it lies in this region, which is red, then it's in that region where we're rejecting. So think about that. If the test statistic is here, then the area to the left of that is going to be less than 0.05. And if p is low, null must go. If the test statistic lies here, then the area to the left of it is going to be greater than 0.05. If P is high, null must fly. And so that's the region where we fail to reject. Okay, let me show you how to find that p-value on your calculator. Okay, so where you're going to find this is in the distribution menu. So you're going to press second and distribution. You're going to toggle down using the arrow key to the chi-squared CDF function. And it's asking for a lower bound and an upper bound. Remember with chi-squared, you can't go negative. Unlike the normal distribution or the student t, it can't be negative. So our lower bound is 0. Our upper bound is that test statistic of 11.311. And the degrees of freedom in this problem is 26. You're going to substitute that into the formula and press enter here. If you have an older calculator, you're going to have to type that in yourself. But let's make sure you understand what's going on here. We're finding the area between 0 and the test statistic of 11.311 in the chi-squared distribution that has degrees of freedom of 26. So the area to the left of 11.311 is 0.00556, which is our p-value for this problem. So that area is 0.005565. That means that our test statistic must be in this red region, this region where we are rejecting the null hypothesis. P is low, null must go. You can see that conclusion on the left side, on the next slide, sorry. 0.005565 is less than 0.05. P is less than alpha. If P is low, null must go, reject the null hypothesis. Okay, so the conclusion is there is sufficient evidence to support the claim that the class has less variation. Okay, let's look at another example. Okay, in this example, example 2, listed below are drive-through service times in seconds recorded at McDonald's during dinner times. Assuming that dinner service times at Wendy's have standard deviation of sigma equals 55.93 seconds, use a 0.01 significance level or 1% significance level to test the claim that service times at McDonald's have the same variation as service times at Wendy's. Notice we're testing the claim that McDonald's and Wendy's have the same service time. We're also given data. So we're going to have to use our calculator to calculate the standard deviation, the sample standard deviation. All right, so go through and set up the hypothesis test, identify the null hypothesis, alternative hypothesis, significance level, and whether this test is left-tailed, right-tailed, or two-tailed. The null hypothesis is that sigma is equal to 55.93. That is our original claim, that they're equal. So the alternative hypothesis is that they're not equal, which is that sigma does not equal 55.93. Significance level is 0.01. Because this symbol in the alternative hypothesis is not equal to, this is a two-tailed test. So now we're going to have to calculate this test statistic. Now I have the sample standard deviation listed here, but you're going to have to do that on your calculator. Hopefully you remember how to do that. You're going to go into Stat, you're going to press Edit, you're going to put those times in your calculator. I've already done that. And then you're going to find the one variable statistics and find that sample standard deviation of 96.240. That's where that came from. Plug it in to your formula for finding the chi-squared test statistic. Remember the sigma is 55.93. And once you type that in your calculator, you get a test statistic of 20.726. All right, so let's talk about that 20.726 for a minute. Remember that the chi-square distribution is different for the different degrees of freedom. This diagram does not show the shape of a degrees of freedom of 7, but it's pretty close with this degrees of freedom of 9. So think about where chi-squared of 20.726 would be. 20.726 is going to be way down here, and the area to the right of that is going to be really small. So when we go to type that in our calculator and find the area, we're going to find the area to the right instead of the area to the left. So let's go to the distribution. Once again, we're going to toggle down to chi-squared CDF. Because that test statistic is so far to the right, and this is a two-tailed test, we're going to find the area to the right. So the lower bound is 20.726. The upper bound essentially has to be infinity. Okay, there's no end to the chi-squared. It goes on forever to the right. So we have to put something close to infinity. So I'll put like, I don't know, 5 nines there. The degrees of freedom for this problem is 7. And we'll paste that in. Those of you with the older calculator, it should look like this. Press enter, and we get a value of 0.0041975,721. That is not our p-value, however. Okay, so pause here for a minute. We get this value of 0.0042. But since this is a two-tailed test, the p-value is actually twice this amount. So twice this amount is 0.0084. And this is our p-value. That's the p-value that we're going to be using to conduct our test. So since 0.0084 is less than 0.01, once again, p is low, null must go. You reject the null hypothesis. So the conclusion is that there is sufficient evidence to warrant rejection of the claim that the standard deviation of the service times at Wendy's and McDonald's are the same. Okay, good luck. Email me with any questions.